Okay, so in this video, we're just continuing practice problems and variations of problems that we introduced in the previous lesson. So we're still working with particularly Maclaurin series in these examples, but Taylor polynomials. So for this first slide, it's just reminding you of the three main functions we focused on: sine x, cosine x, and e to the x, and the patterns that we investigated last class with the Desmos activity. Now, these are the most common three functions you're going to come across that we use to model with, and so it would make your life much simpler in the long run if you became very familiar with them. Of course, you can recreate them as needed, creating our table of derivatives at the given center like we practiced last class. But again, these being centered at 0, very common, and we're going to use them today to do some variations of this. So we're manipulating series, just kind of algebraic stuff. So what if instead of it's e to the x, it's e to the x squared? Or instead of sine x, it's x times sine x, or a combination of these things. So you might be substituting something in for x, or multiplying and dividing by a constant or variable. You may have to combine two types of series with addition or subtraction. And then we've practiced a little bit of differentiating and integrating a series, and recognizing it as a sum of geometric powers. One thing to note for the substitution step is if you use substitution, the center must stay the same. So that's just one thing to keep in mind. And it mentions down here with number 4 that if we differentiate or integrate a series, it may change the interval sometimes, but it will not change the radius. All right, let's jump in. Example 1 says find a Maclaurin series for f of x equals sine of x squared. So instead of sine of x, we're going to convert it to sine of x squared. So the first thing I would do is write down essentially how we think of parent functions and transformations. It's kind of what we're doing here. So the first thing I want you to write out is your parent function, so to speak, of sine x as a Maclaurin series. And as you remember from last class, sine has a lot to do with odd properties. So we have odd powers over their factorials, and then we do have an alternator occurring with negatives occurring on the odd numbered terms if we're thinking of this as term 0, 1, 2, 3, and so forth. And so this was our general term for it. So now essentially what we're doing is we're substituting in x squared. So they are asking for us to create f of x, which is sine of x squared. So basically what I'm going to do is I'm going to go through here, and everywhere I see a regular x, I'm going to put a parentheses, but keep everything else the same. And then it's just a matter of cleaning it up from here. So it should look something like this. All you do is simplify your powers. Remember, a power to a power is multiplication of exponents. So x squared minus x to the 6th over 3 factorial plus x to the 10 over 5 factorial minus x to the 14 over 7 factorial, etc. And then here, just remember when you multiply this 2, use parentheses for 2n plus 1, so it becomes 4n plus 2 over 2n plus 1, and this is a factorial, but my stylus keeps making it go to the next slide and won't let me put a little dot there. All right, so example 2 is very similar, except this time what we're introducing is a factor of some type being multiplied outside of the function instead of inside the function. So again, first write down our parent function. Okay, and remember the cosine one has a lot of even properties. Other than that, is very similar to sine. And basically what we're being asked to do now is to define the function f of x where it is equal to x times cosine x. So it's exactly what you would think. We're going to basically go through and multiply every term by x and then clean it up. I'm going to speed this up. All right, and now we're just going to make it look pretty, and that's really all there is to this. So these aren't so bad. Just watch out for your exponent rules, please. That seems to be the main way we make little mistakes here. And making sure you're not changing anything that has to do with n, only stuff with x's. Okay, so we're getting x minus x cubed over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial plus dot 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 plus the negative 1 to the n is unchanged. This becomes x to the 2n plus 1, but it remains over 2n factorial. Ha, got the dot. All right, so then for the next one, what we're looking at is 4e to the x squared. So a couple transformations have happened here. We're going to start with our base function of e to the x. And this one's probably the easiest to remember the original form of because it just includes everything. There's no negatives, and it's just x to the n over n factorial. So the first thing I'm going to do is the substitution step. So now I'm going to do the function e to the x squared and start with that first. So 1 is unaffected by that. And remember, it just means everywhere there was an x, there's now an x squared in its place. So it's going to turn into something like this. And then for the final transformation, they want us to take that result and then multiply it by a 4. So now everywhere I have a term, it's going to get multiplied by a 4. And I'm going to kind of clean it up as I go for some of these terms. I'm going to put the 4 in front of this guy. Like x squared over 2 factorial is now going to be a 4 times x to the 4th over 2 factorial. And I'm going to clean it up for the final answer here at the very end. A 4 times x to the 6th over 3 factorial, dot, 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 oh my gosh, dot, oh, okay. And then we're just going to get a 4 here at the end. That's going to become x to the 2n over n factorial. So now let's just write our final form. Oh my goodness. I think I'm going to have to pause this and make it work. Okay, I squished it on there. So you can probably leave these unsimplified if you preferred. They're obviously not going to take off anything for not simplifying in general, so I wouldn't stress too much, but sometimes it's nice if they simplify a little bit to go ahead and do that. But that would be your final answer for this particular problem. Now on the next one, it's a little bit more of a headache. So it says find the first 3 non-zero terms in the Maclaurin series for f of x equals e to the x times sine x. So basically what we're going to do here is multiply e to the x form times the sine x form. And obviously this can get a little messy. So if I'm thinking e to the x, and you know, sometimes terms will like cancel. You may need to have more than 3 terms initially, but let's just see what happens. 1 plus x squared over 2 factorial. And sometimes I just like to go ahead. It's kind of like rounding. Sometimes having one extra part will help you be more accurate. So I'm going to go ahead and use 4 terms just to see how it starts looking, and we might not need it, but that's e to the x. And then sine x is x minus x cubed over 3 factorial plus x to the 5 over 5 factorial. And again, just an extra term in case I need it. I don't think I will, but okay. So we're gonna do literally what it's asking us to do, which is to multiply these two things. So for e to the x sine x, we're thinking of those pieces being multiplied. Okay, and you might need kind of scratch paper to think through what this would look like, because I mean we are doing a lot of distribution here, but we really only need what will be our first three non-zero terms. So remember, we're thinking of the order like as in the first, second, and third term by degree, by ascending degrees. So I'm going to start with the lowest degrees, and 1 times x is just x. 1 times that's just going to stay the same. Okay, and I could go over here, but I think it's worth investigating here next because x times x is going to give me x squared. And then I see another degree of 2 times x, that will give me another degree 3. So x cubed over 2 factorial. And I could keep filling this in, but the minute I've continued this pattern, I'm getting things that are of higher degree, which means they're not going to precede the ones we already have. When I multiply here, I'm going to get a 4th degree, 5th degree, 5th degree, like it's just going to keep increasing from there. And since they only wanted the first 3 terms, I have this guy first, this guy, and then I have 2 degree 3s to combine. So that's kind of what we're going to do. We're going to say we have x plus x squared plus x cubed over 2 factorial, which is simply 2, minus x cubed over 3 factorial, which is 6, and we just need to simplify these two terms. That's really what, 3x cubed over 6 minus x cubed over 6, which is 2x cubed over 6, or x cubed over 3. So this means that our final answer for this problem is simply going to be x plus x squared plus x cubed over 3. Okay, now if they had asked for the first 4 non-zero terms, we would have had to look at this degree 4 combined with this one. Like it can quickly get very messy, which is why they're probably not going to ask for more terms than 3 or 4. But let's go write this on our paper. So if we're estimating e to the x sine x with 3 terms, it's going to simplify to x plus x squared plus x cubed over 3, or 1/3 x cubed. And that's it.